So good day everyone and welcome to this video. And welcome again to this video. So our topic will be about the radiation and absorption. Now let's first discuss about the energy radiation and the temperature. So according here, all things both radiate and absorbs energy in all wavelength. All things, meaning to say everything around us, radiate and absorb. So everything around us absorbs all types of wavelength, all types of radiation, and also it emits its own radiation. Let's say for example is the earth. So the earth is absorbing. So it is a body that absorbs the radiation from the sun. So the sun's radiation is being absorbed by the earth. And at the same time, the earth also emits its own radiation. But we have to take note that the wavelength radiated or emitted is different from what it absorbs. So let's have again the earth as our example. So the earth's surface is absorbing the radiation from the sun. So it is in visible light wavelength. So that visible light is being absorbed by the earth's surface. But the earth's surface doesn't re-radiate the same radiation. It doesn't radiate visible light, but rather it radiates in a radiation in different wavelength, commonly in infrared radiation. So the earth's surface is absorbing the visible light, but it radiates infrared radiation. So therefore, the wavelength radiated or emitted by the body is different from what it absorbs. Visible light is very different from infrared radiation in terms of wavelength. So the sun radiates ultraviolet radiation and visible light and infrared radiation. But why is it that this Earth's surface only absorbs the visible light? So here is the explanation. The Earth has its atmosphere and also we have the Earth's surface. So before the radiation from the sun reach the Earth's surface, some of its radiation is being absorbed by the Earth's atmosphere. So mostly the Earth's atmosphere absorbs the ultraviolet radiation and the infrared radiation from the sun, but it allows the visible light to pass through. But not all the radiation, not all the visible light will be absorbed by the Earth, and at the same time, not all the radiation from the sun is absorbed by the Earth's atmosphere, because some of it is being reflected back by clouds, and in the Earth's surface, some of the visible light is being reflected back to space by bodies of water. So that visible light is the only one that passes through, which is not being absorbed by the Earth's atmosphere, and that is what the Earth's surface absorbs. So that is the visible light is what the Earth's surface absorbs. The Earth is also radiating its own radiation, which is an infrared radiation. So it is in the form of heat. So sometimes we feel that the temperature rises. So why is it that the temperature rises, especially in our present day? Why the temperature is rising so much? So it is because of the radiation from the Earth. The Earth's radiation, which is the infrared radiation. And infrared radiation, take note that infrared radiation is a form of heat energy. So some of the infrared radiation, is actually meant to be thrown out to space, but it was trapped in the Earth's atmosphere or the Earth's surface, and the reason for that is the greenhouse gases. So the greenhouse gases is really rising. The greenhouse gases in the atmosphere is rapidly increasing in numbers, increasing in amount. So this greenhouse gases is absorbing the infrared radiation, but rather that it re-emits that radiation back to space, it re-emits the radiation back to the Earth's surface. That's why the infrared radiation that was being absorbed by the greenhouse gases is trapped in the Earth's surface because it was randomly re-emitted by the greenhouse gas, and mostly it is re-emitted back to Earth, then re-emit it to space, directly to space. So that is why the temperature of the Earth is rising. So it has to do with the radiation radiated by the Earth or emitted by the Earth, which is in the form of infrared radiation. So I hope that the first subtopic entitled Energy Radiation and Temperature is already clear. But let's have a recap of that. So again, that all things both radiate and absorbs energy, but what it absorbs is different from what it radiates. So that is the concept of energy radiation and absorption. Now let's have the second subtopic, which is the electromagnetic spectrum. What is this electromagnetic spectrum? So simply, by definition, it is a I guess it is a diagram or that shows the range of frequencies of electromagnetic radiation and their respective wavelengths. This radiation has different frequencies and wavelengths. So that is the role of the electromagnetic spectrum. It shows us the wavelengths and the different range of frequencies of those radiation. So in the electromagnetic spectrum, you will commonly see the gamma ray, the X-ray, the ultraviolet ray, and the infrared radiation, microwaves, and radio waves. So where is visible light found in the electromagnetic spectrum? So the visible light is found between the ultraviolet and the infrared radiation. So why is it called the visible light? So because it is the only radiation visible to the human eye. So the human eye can see the radiation visible to the human eye has the wavelength of about 400 to 700 microns. So if the wavelength is about 400 to 700 microns, that is in visible light form, which is visible to human eye. While most of the radiation found in the electromagnetic spectrum are invisible to the human eye. Now let's have a third subtopic, the radiation intensity and the temperature. So intensity of radiation, it is the energy emitted per unit volume of the emitted light. So it is measured in joules per cubic meter. So the intensity of radiation, how intense the radiation is. The intensity can be increased by raising the energy content or by reducing the area into which a unit of energy is emitted. So that is the factor that could affect the intensity of the radiation. The rising of the energy content or the area where the energy is being emitted. Now we have the fourth subtopic, the Stefan-Boltzmann law. It states that the intensity of radiation is proportional to the fourth power of temperature. So the formula is the intensity is equal to the Stefan-Boltzmann constant times the temperature to the fourth power.
So good day everyone, I am here to discuss about the Planck curves and the ultraviolet catastrophe. So Max Planck of 1858 to 1947 solved the ultraviolet catastrophe. So it is in 1901. The problem of the ultraviolet catastrophe is that an object called black body emits electromagnetic radiation of all wavelengths. So ultraviolet catastrophe is an object that absorbs all radiation it receives and radiates all the energy it absorbs. So black body is not just a perfect absorber of radiation, but also a perfect emitter of radiation. So that is the problem of ultraviolet catastrophe. It is because of the black body. So the sun is an example of a black body. A hot piece of metal is one also of the example of black body. The black body spectrum depends on a temperature. So as wavelength shortens, a black body at a given temperature emits more radiation. So this is why hot objects will glow like hot oven, light bulb, or a sun, and other stars. So because of hot objects, it emits a lot of visible light. So human body temperature. So our temperature is around 310 Kelvin. It emits essentially no visible light, which is why we can see each other in the dark. So because of that, we don't see each other. So I can see you when it is dark, so you can see me when it is dark too. So cool objects emits almost zero visible light. So the problem with the black body is that classical theory, which is the 5,000 Kelvin temperature, couldn't account for this distribution. So the experimental data illustrates that longer wavelengths seem to work fine, but it not predict that shorter wavelengths were not predicted to decrease in intensity. So according to the math predicted that shorter wavelengths were predicted to increase to infinity. It means the intensity continued to increase as wavelength decreased and become infinitely large as the wavelength approached zero. So the classical models therefore don't match the reality. So in science, when the theory does not align to the observation of reality, it must be discarded or revised. So Max Planck created the solving the Max Planck solved the problem by implementing quantization. So Max Planck proposed that the vibrational energies of the atoms are quantized, meaning they can possess just any value. They can only possess certain discrete values. So that's how Max Planck solved the ultraviolet catastrophe by quantization or quantum. So we are rescued from the ultraviolet catastrophe. It is because of the Planck curve. It is because of Max Planck. So there are Planck curves, several important features of the relationship between energy intensity and its wavelength. So first, as temperature increases, the peak intensity is at lower wavelengths. So in means low, it it means that as temperature rises, the peak intensity occurs at short wavelengths. So, and it's shown by the dashed white curve. So, second, before any chosen wavelength range, the total intensity emitted is greater at higher temperatures. So, meaning the sun emits more intense radiation at all wavelengths than does the Earth. So, third, a cool body like Earth will radiate in the longer near infrared and infrared ranges. So it is as if higher and higher speed bumps. So Planck created the solving problem. He solved the problem of ultraviolet catastrophe, but Planck created more problem. So the question is, why is there a quantization of energy? So it is the problem now. So this marked the beginning of quantum revolution in physics. So Max Planck created the solving of the problem of ultraviolet catastrophe, but Planck created more problem. That's why it is the beginning of quantum revolutions. So that's it for the Planck curves and the ultraviolet catastrophe. So let's move on the energy emission and atmospheric absorption. So the figure that I am discussing now is the wavelength emitted by sun and absorbed by Earth. So the figure below shows the proportion of light emitted by the sun, which is the red line, and each wavelength and the proportion of the radiation absorbed by Earth's atmosphere, which is the white line. So the red line is the light emitted by the sun. The white line is the radiation absorbed by the Earth's atmosphere. So the sun emits about half its energy in the UV light and visible light range, and about a quarter of its radiation in the UV and infrared ranges. So on the other hand, Earth absorbs most of the sun's UV radiation and infrared radiation, leaving the visible light to pass through the surface. So it means that our atmosphere gives us what we need, which is the visible light, and stops much of the bad stuff, which is the UV light. So meaning our atmosphere helps us to stop the bad light entering the Earth, which is the UV light. So atmosphere stops that, and um, it passed through it passed through the visible light. So that's it for my report, and the other figure will also discussed to us by Mr. Reymart Boybanting.
So thank you. So we have this second figure. So this figure shows the wavelengths of the Earth's radiation from its internal energy and re-radiation of the sun's energy. So the Earth's radiation, the radiation that the Earth emits is the one in blue line. And the sun's energy is the one in the white line. So as the sun's radiation. So as you can see, the Earth is also emits its own radiation. And also you can see that there is a radiation from the sun being absorbed by the Earth. So based on the figure, the Earth's atmosphere is already absorbing some of the sun's radiation. So you can see that the Earth's atmosphere is already absorbing some of the sun's radiation, which is the UV and the infrared radiation. And inside the broken lines, there is also radiation. It means that, and that radiation is the visible light. It means that not all the radiation from the sun is being absorbed by the Earth's atmosphere, but some of its radiation is being absorbed by the Earth's surface. So as you can see in the figure, the Earth's atmosphere is absorbing some of the sun's radiation, but there are also radiation that passes through the Earth's atmosphere and isn't being absorbed by the Earth's atmosphere, and that is the visible light. And as this Earth's surface absorbs that visible light, it will also emit its own radiation, but in different form, in different wavelength, which is in infrared radiation. So thank you for listening, and God bless you.